So here's our last little section for our animal friends, animal phyla. It's interesting now we're getting to this point here where we can talk about deuterostomes, and we're going to change this in a bit at the end of the lesson, which is kind of important. But we're going to catch our echinoderms here in chordates, which mention the deuterostomes. And if you remember, it meant to be formation of the mouth was our protostomes, mouth first, anus second. Well, in deuterostomes, the anus forms first in gastrulation. That's that infolding of that blastula, that hollow ball of cells. Okay, so we're related to echinoderms on that group because of that primary gastrulation. And then we're going to reclassify this in just a bit. So we're going to get to that, okay? So this is sea stars. We call them starfish. Sand dollars, you know what those are, and sea urchins. Yeah. Basically slow moving, or even sessile, which means they don't really go anywhere. Saltwater, mostly show radial symmetry, which, let's go back to this too. Not the dot, that. So radial symmetry is found up in the cnidarians, and then we see bilateral symmetry all throughout here. However, it's not exclusive. So these echinoderms, as we're mentioning here, are going to show radial symmetry as well. So not exclusive. Echinoderm, the derm piece is the skin, right? So prickly extensions. If you've ever held a starfish, whether it's a skeleton, you can notice it, but you still notice it when they're alive. The prickly extensions. This water vascular system is kind of cool. It is unique to echinoderms, so they're the only ones that do it. Fluid-filled canals that branch into the tube feet. This is what allows them to move as well as prey upon their quarry. So tube feet, and you can see it here, tube foot. So it forces its stomach. So if you've ever seen one of these, we call them shells, like at a boat launch or something, a bivalve, it's actually boring a hole through its opening and then forcing its stomach into the internal viscera, and it's going to digest it that way. So this is where it says echinoderms or deuterostomes. So more related to chordates than they are to the other groups that you might have thought. Okay? That takes us to chordates, and this is us. Right? 4 identifying characteristics, either as an embryo or an adult or both. These are the 4 characteristics here. You'll expect to be able to articulate these on your test, right? So they have this dorsal hollow nerve cord, and that refers to the back and dorsal, and then the hollow, that's where the nervous tissue is going to run. Okay, so we can see it. I'm going to toggle back and forth a bunch here. Dorsal hollow nerve cord, that's the yellow stripe. That's where the nervous tissue is going to go. Then we can talk about the notochord, which is ultimately going to become the bone in us that supports us. Toggle back and forth, go away, dissolve. Flexible, supportive, longitudinal rod. This little basic body plan that we're looking at here is a larval stage of tunicates and lanceolets that makes them chordates, but they're one of the 4% of chordates that don't show these characteristics as adults. They only do it in the larval stage. But those of you with imaginations, I know you can see that this guy here is one of those embryonic looks that humans might demonstrate, or turtles, or whatever, fish. This is the basic body plan that leads to the tetrapod body plan in those vertebrates that are tetrapods. Okay, pharyngeal slits become gills or lungs. We can see them in pink here. So during development, they're located forward. This looks like a tadpole, any number of juvenile vertebrate creatures. And then the tail that extends beyond the anus, which is back here. Those 4 characteristics, either as a juvenile, an adult, or both, okay? So this tunicate here, which is pictured, stationary sacs adhere to rocks, corals, boats. They're very simple lifestyle, but they also are our predecessors. But the adult doesn't show the notochord, nerve cord, or tail, but it does have the pharyngeal slits. Okay? And this is a lancelet, which looks, appears to be a little bit more advanced than larval stage. So this is an adult. Let's move this right there. Small blade-like chordates live in the sand, so you can see how it kind of burrows into the sand. And there's the four major characteristics. This looks largely like some sort of fish, and you'd probably confuse it for that if you were to stumble across it in the water. Okay, brings us back to changing the phylogeny. So what we're going to highlight here, these two stars on the lower right-hand side, here and here. Deuterostomes doesn't change. This group stays what it is. But now we have Lophotrochozoans and Ecdysozoans that have been broken into two independent groups from protostomes. So remember, in gastrulation, these guys will form the mouth prior to the anus forming in that primary move. So the difference now then becomes that during development, these guys, a feeding apparatus for the larva and the mollusks and the annelids that doesn't exist in the ecdysozoans, and these guys have exoskeletons which must be shed. So these are your ecdysozoans, and these are your Lophotrochozoans. So if you look over here, they were all grouped into one group. Other thing to remember is that this no true tissues description has now been branched off into three independent branches up here, but we're not discussing the differences in this particular setting. All right. So just understanding that phylogeny, taxonomy, cladistics, systematics, they're also evolving as we move forward. From our meeting today, this is where I thought you had been, but you hadn't. So just use this as you practice for your test. These are the terms you're going to want to know under phylum. Come back to this. So these are going to be the common names, and you will be responsible for the actual phylum names. So what you might want to do on your test, don't call them sponges. You're going to have to call them porifera. So you might just want to, as you practice, not a V. You're going to want to go ahead and put porifera in there, and then cnidaria. So that one's very similar. And if you remember, flatworms, Platyhelminthes, Nematode, Mollusca, Annelida, Arthropoda, Echinodermata, and Chordata. So they're related, but I want you to use these terms. So just type them in where necessary for you. And then the description that I'll use on your test is going to have this nature to it. Come down here, 4 chordate features. Obviously, I'm not going to say that. That's going to give it to you. So I'll come up with something different. So remember, and for the picture section, a characteristic for the vocab section, sponges are the poriferans. So if I put a picture of a sponge or put a picture of these guys, you have to relate it over here. So just prepare using this, and you'll be fine. Now this one is also a good one because this chapter is about development. So I want y'all to watch this. It's either 9 or 19 minutes. Can't remember which. This might be the one that's 9. You'll figure it out. You'll have the time. So watch this, and it talks about human development, chordate development, and how remarkable that it is with the limited number of mistakes that it makes during that time. So please get into that and enjoy it in preparation for your test. All right? Good. I'll see you when we take our test on Friday at 10 o'clock.